Hi, and welcome back to the Save It for Parts channel, where today I'm building a helicone antenna. Now, I've built one of these before, and this is the one I built previously. This is designed by Tonito, and it's available on Thingiverse. It's mostly 3D printed, and then you use some window screen, some copper wire, and a few bolts here and there. I actually used quite a bit of hot glue when I assembled this instead of the screws that you're supposed to use, and honestly, it's held together fine. I normally have this mounted on a Motorized base, one of the Winegard satellite antennas that I've hacked. And it works really well for picking up weather satellites like Meteor, like Metop, previously the NOAA series when those were available. Any L-band circularly polarized satellite, at least right-hand circularly polarized, because this is an RHCP helix in the middle. And it may look like a dish, but it's not actually a satellite dish. This cone thing around the back is more of a ground plane. It's not really a true reflector. It is focusing the signal onto the helix, and it's helping the helix get more signal. But if it was a true dish, the helix would actually be mounted backwards in front of it because a dish reflects the signal. It's also called a reflector. But yeah, this is kind of a weird hybrid between a directional handheld satellite antenna and a dish. Not truly a dish, kind of helps you get more signal than just the helix by itself. But yeah, it's a nice compromise. It's small, it's handheld. You can print a handle for the back of this. You can put your amplifier filter unit in the handle. You can basically have the whole thing self-contained, hook it up to your computer with a software-defined radio, hook it up to your phone. I really like it, and I've been using this one quite a bit, but like I said, we're building another one today because this isn't super portable, and I want something that I can bring out to OpenSauce 2026 in July, and I need to kind of pack light. We're doing some other stuff around that time. I need to have as little equipment as possible in my luggage, and this takes up a lot of space. So this one is a slightly different helicone design. This is by Riche on Thingiverse, and they're also on my Discord. So if you want to talk to the designer, my Discord is a great place to find them and a lot of other people who design cool stuff like this. I don't know how to design this level of 3D printed equipment, so I'm happy I can just throw the files into my printer and it spits out a bunch of plastic. Now I have to go through the instructions and figure out how to assemble this. And what's different about this one is that it's supposed to fold up. So it is supposed to be more portable than kind of the static, the original design over here. I have some copper wire left over, and I think it's even coiled in the right direction. And since this is a folding one, I need something more flexible than the metal window screen that I used on the old one. So we're going to try this Faraday cloth. I have some scraps that someone gave me from another project. And since the hot glue worked so well on this one, we'll probably try some hot glue on the folding model as well. I was originally just going to film the assembly of this as kind of a little brief snippet inside of a video about OpenSauce, and I probably will still include it in the OpenSauce video, but I figured this will probably take me all day to get this assembled, so I might as well make a full video about it. Now, these helical feed scaffolds that you put the wire into are something that I've struggled with in the past on various 3D printers, and I actually finally have a 3D printer which will handle this complex shape and will print these three towers without separating them at the top, which has kind of been an ongoing problem. And the 3D printer I'm using these days is the Prusa Core 1L. I think this thing is fantastic. It's got the enclosure so the temperature stays controlled. It's got a bunch of great filament options. I've been using the PC Blend a lot lately, and that's been great. It has worked fantastically for complex shapes, problematic shapes like those antenna scaffolds. Now, Riche says this is a little more expensive due to all the little bits and pieces needed, but as a professional hoarder with a garage absolutely full of junk, I think I probably have all the bits and pieces already. For example, instead of buying brass rod, I have these steel rods from Utility Flags. A little rusty, but I can clean that up. And I also have this sheet of metal that I can cut to the right size for the inner ring. And I probably have enough little screws and fasteners and whatnot for the parts that don't get hot glued. All right, so let's see about getting this thing put together. I don't know how much of a time lapse this will end up being because I don't know if my camera battery will last through the entire process, and we might have to stop and come back if I'm missing a piece, but we'll see how much we can do. right, so this should be about done. I went ahead and soldered in the antenna connector and the helix, and I really like the way this folds up. Like, it's actually stable in both configurations with just some rubber bands on the bottom, so when it's all folded in, that is much more convenient than the other one. And then when you start to fold it out, it kind of pops open there. It's still a little floppy around the edges. I'm supposed to put an elastic band around the perimeter here, and I don't actually have one big enough. I think I have one, I just don't know where it is. So until I find that, it's a little bit loose, but it's still forming approximately the right shape here. And yeah, it's very easy to fold up, very easy to deploy. Yeah, this thing is fantastic. I like this a lot, but we need to find out, will it work to pick up satellites? And yeah, I'm a little uncertain if it'll work to the best of its ability without that perimeter elastic kind of tightening up this loose edge, but I kind of want to try it anyway. Also, I did not put in these interior supports that are supposed to go on the inside of the legs. These are supposed to screw through here and clamp the Faraday cloth or material in place, but I just used some hot glue, and this is super strong. The hot glue really bonded with this Faraday cloth. And I did test the Faraday cloth here. Yeah, you can hear it beeping basically all the way from the Faraday cloth to the center and all the way to the outer part of the SMA connector. And then I did verify that I have my center pin of the SMA connector. I have continuity between that and my helix. Now, just like the other one I showed, this is supposed to have a handle on the back, so you can hand hold it, hand aim it. I'm intending to mount it on a motorized base. It's going to be kind of a demo at open source, so I'm going to have this on just the motor part of a Winegard antenna, not the entire radome and everything. But yeah, for that I don't need the handle, so I didn't bother printing it. I think I can still get a handheld pass if I just I can just hold the rubber bands on the back, or if I put a Sawbird filter on here, I can just hold that, and that should be enough to give me a baseline test for the thing. All right, we gave the folding helicone a very brief test. I aimed it at GOES 19, GOES East. That is the geostationary weather satellite. It's kind of a default test satellite. These helicones are not big enough to actually decode anything from that satellite, but they can see it, and both of these can see it the same approximate signal strengths. And I did try just a bare helix with no cone around it. That can't even see the telemetry signal from GOES, which is usually really strong. So we know that the cone is doing something because this one can see the signal even if it can't decode it. So next up, I'm going to try this on some actual low Earth orbit weather satellites. I kind of think it's going to be a choppy decode. It's going to have a lot of lines in it because I'm not good at hand tracking. It's a low pass. I've got Met-Op B coming over at about 30 degrees, and then I've got one of the Russian Meteor satellites coming over at about 30 degrees. So they're not direct overhead passes. Somebody's street racing there. They're not direct overhead passes, so I probably won't get a great signal, but hopefully I'll be able to get something out of this. All right, I had low expectations for that pass, and it kind of lived up to the expectations. Met-Op B is challenging to receive even in good conditions, and this was marginal conditions, low pass, kind of behind the trees, new antenna. My hand tracking is garbage. A lot of the professional-ish satellite tracking people say you can do it by just watching the polar plot and the signal strength in SDR++, but I am no good at that. All right, the sun has set and my camera is running out of battery power, but Meteor M23 is coming over in a moment here, so let's see if we have any better luck with that one. Okay, that pass seems to have worked okay. Probably not great, but definitely okay. All right, so that's a usable Meteor M23 capture. It's not the prettiest, but my hand tracking passes never are. You can definitely see the Great Lakes, you can see cloud patterns. Yeah, this is a perfectly reasonable satellite reception using that folding helicone. So I'd say this thing is a success. So now that I've made this thing nice and small, I'm gonna make it bigger by slapping a motor on it. And that might be silly, but that's kind of part of my demo at Open Source, is I want to use this as a motorized azimuth elevation tracking thing. So to do that, we're going to use another one of these Winegard carryout dishes. That is what I use for the motor on the other one. But since I'm bringing this out to a convention, I still want it to be as small as possible, even with the motorized base. So we're going to tear this thing down, maybe get rid of the dome, the base structure, and just use the motors and the control board as small as possible. I need to 3D print a new base for this so the cable can come through. So we're literally just going to design this on a napkin and then 3D print it. And I might actually want to print that handle and have it interface here because this can't really sit right on the plate. It won't fold up anymore. I brought this thing in to measure it again, and Fluff has immediately colonized it. Hi, do you live there now? So I was puttering around with this thing inside and realized there's actually a pass of Meteor M23. It was in like 10 minutes when I noticed it, and this thing takes about 10 minutes to do its calibration dance. So I ran outside, set everything up, and we're gonna see if we can receive the signal from that on L-band. Well, the tracking seems to work. I have not used this particular brain and motor system from this Winegard dish before. It's just one of my spares, and I had to wiggle a few things, but we got it working. Now the wind is blowing around that Faraday cloth quite a bit. I really need an elastic band around the rim of the cone, and that is what Riche recommended. I just have not found one yet. So, although it actually looks like a pretty decent signal if you ignore all the screen glare. And as soon as Meteor M23 finished passing, Metop B showed up. So I'm going to try that one as well. That one has a little bit of a wider bandwidth than the SDR that I'm using is normally capable of. I'm just using an RTL SDR V3. They're only about 2.5 megahertz bandwidth, and I think Metop is 4 megahertz. Anyway, usually I use the Hacker F1 for that one, but we'll try it on this one anyway since it's already set up. So the captures from Meteor M23 look really good. Like, these are just as good as images that I get from the regular helicone on the motorized tracker. So yeah, I would say this folding one performs just as well as a rigid one. At least it did for me. Now, I still have those floppy edges in the wind. I did get a little bit of static when it flopped a particular way, so I think an elastic band of some sort would help, but I'm really happy with this. For Metop B, we really only got the topmost part of the pass, and that's about all I expected with the RTL SDR. It's just not really appropriate for this satellite with the wide bandwidth signal, so I'm happy we got anything out of that. All right, I like this thing so much that I made another one. This is just printed with PLA for this one, and I tried a little bit different design on the cone. This is just triangles cut out and then individually hot glued onto the arms, and that seems to have done a little bit better than trying to do one big circle with a slot in it and trying to fit it on here. I think that would work better for a stretchy fabric. This isn't super stretchy. This is just a different kind of Faraday cloth. So yeah, this one actually I think looks better than the first one I did, but I made this one as a gift to give to a friend out in California. So I will not be using this one at Open Sauce, but I did make it the handheld version. So I've got the handle here. I've got the LNA inside the handle, and then I can just bring this out and hook it up to an extension wire or to a SDR on a USB cable. Kind of have to fold them all up at once or they want to pop back out, but yeah, works pretty well, and then deploys back out. That is fun. I love spring-loaded gimmicks, and this is a pretty good gimmick. Now, I did hand hold this one for Meteor M24, and I'm terrible at hand aiming these antennas, so we'll see if we get anything out of it this time. All right, that turned out pretty well. I did get a bit of static in some of these images. Like I said, my hand tracking skills are not the best, but other images turned out really well. Some of these, I don't know what's going on with some of these. I think we have an error in one of the sensors on this Meteor satellite, but yeah, some of these turned out really well. We can see the Great Lakes very clearly, Midwestern US, a little bit of the East Coast. All right, we brought this rig out to California, and we're giving it a try out here with a couple different satellites. We're trying some of the Meteor satellites and Metop. And for Metop, I had to borrow a Hacker F1 because I did not bring mine. Yeah, it's popped out again. It's like anytime I touch this, it pops in and out of the USB connection, and then it
freezes up everything on the laptop, which we can't see because it's glary, so not an optimal setup at the moment.
I was able to capture a few images from both a Meteor satellite and a Metop satellite out in California. Now, these are a little more staticky and not quite as good as the ones I got at home, possibly for a few reasons. First off, we were in the middle of the San Francisco Bay Area, which is a much denser urban center. So there's a lot more radio interference, there's a lot more electronic noise than there is at home in St. Paul. And also, I'm not as familiar with the area, so I was a little bit off on where north was relative to where I was hand holding the antenna. So I think I was a little bit inaccurate with my hand tracking. I will try this again with the other helicone when we come out for open source, and we'll see how the automatic motorized rotator does compared to my hand tracking. It was definitely still fun to get a different weather image. Typically, I just see the middle of the country. All I ever see is farmland. But here in the Bay Area, I can see the Pacific Ocean, we can see the coastline, we can see weather patterns coming in offshore. That's pretty cool. Again, huge thank you to Riche for inventing this, for making the files free available on Thingiverse, and I will put links down in the description, as well as probably up here in the corner where you can download the files for this if you have a 3D printer. Yeah, I would recommend making this. It's really fun. You can get several satellites with it, at least 4 here in the US. You can get both Meteor satellites and both of the Metop satellites if your SDR has a wide enough bandwidth. This thing is fantastic. Much more portable than the other helicone that I've tried before. I do like Tonito's original design. It's just not portable. And this one, yeah, you can fold it up, you can pop it out, you can put it in a backpack. I really like it. If you want to see the motorized version of this antenna in action, along with some real-life demonstrations and some of my other DIY antennas, I will be exhibiting this and some of my other stuff at OpenSauce in the San Francisco Bay Area, July 18th and 19th. That will be at the San Mateo Convention Center, and that is a great convention. OpenSauce is fantastic. We went back in 2024 and it was just a ton of fun. It's a lot of science nerds, a lot of big name YouTubers, a lot of really cool projects made by small-time creators, by students, by people who are just really, really in love with DIY, with making, creating, with experimenting, and it is a fantastic time. Well worth the admission price. It's 2 days of fun, and you can't even see everything in 2 days because it is just that big and that interesting. So I would highly suggest anyone in the San Francisco area, anyone on the West Coast, come to OpenSauce. Meet me if you want to see some of my nonsense creations, meet a bunch of other cool creators, see some YouTubers talk up on stage live, and just have a good time. I'll put a link down below to the OpenSauce convention as well, and I might even have some special gifts to give out to Save It for Parts subscribers who come and find me at OpenSauce. Come and find my booth and ask me about it, and depending on how much stock I have left, I may or may not have some antenna things to give away. We'll see what happens with that. Thank you to all my Patreon supporters for helping me fund satellite nonsense and continue buying $50 Weingard dish brains to tear apart and repurpose. If you like these videos and you would like to support future satellite adventures and experiments, please feel free to support me on Patreon. I will put links down below in the description. Viewers on Patreon get to see my videos a week ahead of time, and you get to see some other things here and there that maybe YouTube doesn't like. So you not only support the channel, but you get to see some extra stuff and you get to see everything a little early. Finally, thank you to everyone out there for watching, and we'll see you next time.